All right, so first of all, I'm obviously upset that I can't be in class today, but this is something that I was going to kind of try because we do have to get on with polynomial functions in our study of them. So if at any point during this you have any questions or anything, just write them down. I'm hoping to be here tomorrow, but if not, then we'll kind of continue to work with it. But write your questions down if you have them. You can email me at any time, and I'll try to get back to you as soon as possible. If not, then the next time I'm in class, I can answer any of the questions you have. But make sure that you write them down and keep them. Don't just kind of think about them and let them go to waste if indeed something comes up that you don't understand. What I'm going to kind of try to do is explain just like I would in the regular class, and then work through a couple of example problems and then cut you loose and let you get some of the work done. If obviously if you don't understand it, it's not the end of the world. Please just bear with me, do what you can, and then when I get back, we will we'll continue to chop away at this stuff. But kind of moving on with our study of polynomial functions, we've already talked about the leading term test. We've already talked about zeros and turning points of polynomial functions. The last thing that we did was, I cut you loose and let you work on some of this guided practice on page 100. So if you'll open up your book to page 100 and kind of follow along, that would be extremely beneficial. I think a lot of y'all were struggling with 3b here underneath example 3. So that's kind of where I'll start off, and I think that it leads into our next conversation very well. So let's look at, we're on page 100, and let's look at 3b. Again, we're looking at finding the zeros of these polynomial functions. There's some information that we can get though before we even look at the zeros, based on some of our other study. But the function that we're asked to look at here is f of x equals x to the fourth minus 8x squared plus 15. Okay, now this isn't really like anything that we've seen before, but if you really think about it, it is factorable. All right, but remember, when we're trying to find the zeros, and really when we get a polynomial function, we're just kind of trying to gather all of the information that we possibly can. And a lot of that will come from this leading term, x to the fourth. If you remember, the last thing that we said is that any polynomial function is going to have at most the number of real zeros as the degree, and at most one less turning point than that. So our highest possible number of real zeros is going to be what? 4, because that's the degree, right? And then our highest number of turning points in the graph, all right, which we're not really going to worry about just yet, but it is part of the wealth of knowledge that we can go, or that we have already. Is 1 less than that, or 3. All right, so important to kind of gather all the information that we possibly have. Again, we're trying to find the zeros because that's just giving us more points that we're going to be able to graph and kind of see the shape of this graph as we move forward. We know that the left end behavior is going to be positive, or as x approaches negative infinity, f of x approaches positive infinity, and as x approaches positive infinity, f of x approaches positive infinity. And we're trying to find some points in between there to see, kind of get a better picture of what's going on. And so again, if we're looking at this function, we can't really find the zeros based on anything that we've seen before, but if you look at it very closely, this is factorable. Remember, when we are trying to find the zeros, we're just going to take that polynomial expression and set it equal to 0 and look for the x values that we can plug into here to make that expression true, or make that equation true. And so again, when we look at this at first, we don't really see anything, but I think you should be able to see that this would end up, squared, would end up working for us. All right. If you want to, go ahead and FOIL that out, and you'll see that if you do FOIL this out, you will end up with this expression. And just in just a little bit, I'll explain to you exactly how I got that, but this definitely works. And then, so from here, it's just kind of like when we were doing quadratics. We know that we can kind of set up these two equations as well. If this whole thing's going to equal 0, then one of these two has to equal 0, right? So either of these things has to be the case. And then for each of these, if we continue to solve, square root, when we take an even root of an even power, we need our plus or minus. So we got plus or minus 5 over here. And similarly, over here, we can see that we're going to end up with plus or minus the square root of 3. I think I said plus or minus 5 over here, plus or minus the square root of 5. But again, even root of an even power, we have to add our plus or minus. And so the 4 roots that we were expecting, the highest possible number of real zeros, we get 4, right? Positive square root of 5, negative square root of 5, positive square root of 3, and negative square root of 3. And so those are my 4 answers. Okay, not necessarily something that I would have expected you to do up to this point, but it does make a lot of sense, right? Because what is factoring other than being able to kind of go from a polynomial expression and write it as the multiplication of its factors? And that brings us into a situation that'll make our lives a lot easier because of the intensity that we studied quadratics with. And all that is quadratic form. This past problem we were allowed to do because it was in quadratic form. And there is a box in your book right there at the bottom of page 100 that explains what quadratic form is. But basically, it allows us to take something that's not quadratic and make it look quadratic. Because we've studied so much how to solve quadratics, this makes our lives a whole lot easier. So a polynomial expression is going to be a quadratic form if it can be written like this: AU squared plus BU plus C and there, there's a bunch of other stuff in that. It says for any numbers A, B, and C that such that A is not equal to 0. And the important part is that where U is some expression of X, or some expression in X. Okay, so what does that mean? U being an expression in X, basically U is going to end up equaling something that has X in it. So for instance, if we look at this last problem that we just did, X squared minus 8x, x to the 4th minus 8x squared plus 15. Okay. It may not make a whole lot of sense what this quadratic form is right now, but basically what it is if I were to say that U equaled x squared, so we kind of go off to the side and make that declaration, what would this become? I want you to kind of think about it for a second. Basically, if I treat this x squared as a U, and I'll kind of take you step by step there, this x to the 4th is really x squared squared. This x squared is obviously x squared. And this 15 is unaffected by x anyway. And so all that means is that I could rewrite this as u squared minus 8u plus 15. And now what do we end up with? This is quadratic that we know how to solve, which we could do several ways. The way that I did it was just to factor it, looking for numbers that multiply to give me 15, that add to give me negative 8. So I went u minus 5 times u minus 3. And then basically we plug back in this terms of x back into it, and I ended up with x squared minus 5 times x squared minus 3. Okay, so this allows us to solve, several types of problems that are going to be really helpful if we can write them in quadratic form. Example 4 kind of shows you that. If you walk through that example, what I'm going to do, since I'm limited in time with the videos that I can make, I'm going to try to walk through guided practice 4A and 4B right here. So when I get done this, make sure that you look over example 4, but I'm going to move on to guided practice 4A and 4B to give you another example of how this should work. All right. So 4A gives us g of x equals x to the 4th minus 9x squared plus 18. And so we can see pretty clearly that this is the same type of problem where, again, we're trying to find the zeros. But this is the same type of problem where if I rewrite, and again we set it equal to 0 to make it a polynomial equation that we can solve. But if we rewrite this with u instead of x squared, okay, we can see that x to the 4th is u squared minus 9u plus 18. And from there, let me do one in quadratic formula just to show you how that works. If we wanted the quadratic formula of this, we have, remember, this time u equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so u equals 9 plus or minus the square root of 81 minus 4 times 18, which is 72, I believe, all over 2. And so we end up with 9 plus or minus square root of 9 over 2, 9 plus or minus 3 over 2, which would give me, what's that, 3 and 6. All right. The problem with this now is that u is equal to either 3 or 6, so those aren't my answers, right? Basically, we'd have to go back and re-plug in my x squared for that u, so basically I end up with these two equations, similar to what we had last time. But I basically have x squared equals 3 and x squared equals 6. And from there I can solve to get my 4. So this would have given me 2. And then when I plug back in that x squared, take the square root of both sides, get plus or minus the square root of 3, and plus or minus the square root of 6. So there we go. I've got less than a minute left on my allotted time. I think this should be pretty good to be able to ask you to do what I'm trying to get you to do. In 4B, you're going to have to factor out an x before you put it into quadratic form, but that shouldn't be an issue. And for some of the classwork and homework problems, you may have to kind of get it to a point where you can put it in quadratic form, but all of these are dealing with that. So thank you for your attention. Hopefully this was, a meaningful way to use our time, and I can't wait to see y'all tomorrow. Good luck.